Hi everyone, my name is Dan and I will be giving this 1 hour lecture here on natural language processing. So myself, I am a postdoc in machine learning here at the University of Bristol, and this 1 hour lecture, I've decided to split this lecture into 4 parts, so also 4 videos, where this first video will be about a general introduction to natural language processing, also called NLP. So this is entitled The What, Why and How of NLP. So we start with just a few examples of where NLP is used. So NLP could be used by Google to analyze all the search queries that you put into their search engine. It could also be used by Apple to develop and further develop their autocorrect feature on their iPhones. It could be used by BBC and all other news agencies to analyze their news articles. And it could be used by review platforms to analyze all the reviews they are receiving. So what is natural language processing exactly? So it's kind of in the name. It's about the processing of natural language being human language as opposed to code language, for instance. So we could define natural language processing as the study of extracting information from text. There are various tools out there that use this method, or use techniques from this field. So this could be search engines, as we saw before, could also be machine translation. So think of things like Google Translate, voice assistants. So whenever you use Siri or Alexa or Google Assistant, they are all using natural language processing. So keep in mind that natural language processing is not specific to text. It can also analyze audio, although in this lecture I will solely be focusing on the text aspect. Can also be used by chatbots. So this is usually employed in customer service applications where you want to get help with some product that you have purchased or are wanting to purchase. And a chatbot can, in many cases, help get you immediate service. Spam filters in your email, auto-completion and autocorrect on your phones. Whenever you use a grammar checker, if it's an advanced grammar checker, so think of when you use a grammar checker in Word or on Google Docs or something along those lines. And lastly, but perhaps most importantly, whenever you have a big chunk of documents and you want to do some bulk analysis of them, like there are simply too many of them for you to manually analyze them. So think, for instance, back to the BBC example, where BBC, they have thousands and thousands of news articles. If they want to extract some statistical information from that, they would have to extract information from the text rather than doing it manually. Right, so why natural language processing? So firstly, as I mentioned, it is our natural way of communicating. Like, text is present in documents, emails, social media, news articles, and also podcasts. Any medium you could think of which involves any kind of text or audio. So a consequence of this is that we have lots and lots of data available, primarily on the internet, but also through, again, books and podcasts and so on. And the thing with all this text is that usually it would be intractable to manually analyze all of this data because there are just millions and millions of documents out there. So we need an automatic way of analyzing and processing all of these documents, and this is where NLP enters the picture. So one might ask, how can we even process natural language algorithmically? How can a computer understand natural language? So if we take a sample sentence here, I really liked Ali Smith's new book. So all you would get if you were the computer or the algorithm is you would just get a sequence of characters. So this sequence that we see right here on the screen. So how can you extract the meaning out of this? What's the meaning of the capital A in Ali? How do you get to the conclusion that Ali is a name, is a first name even? And also, there are more than 170,000 words in English. So this is according to the Oxford Dictionary. Others claim that there are more than 1 million words in English if you include slang. But you have to somehow account for all of those, or at least most of those words in your algorithm. And how can you even do that? So these are the questions that we will, that I will attempt to explain, like how the current methods are dealing with these issues. So there are different ways that we can do natural language processing. So it's one thing just to say we want to analyze natural language, but what do we actually intend to do? So one category which is very popular is called document classification. So this is, you're given a document. Again, if we go back to the BBC example, this could be you are given a news article and you want maybe to categorize these news articles in topics, for instance. So this would be a classification task where you're given a document, just a sequence of characters, and you want to classify this sequence of characters or this document into a preset number of classes or topics, if we take that example. It could also be reviews that you want to categorize in some way or another. So within the document classification category, we have, well, at least 3 different kinds, which are just ways of setting up your categories. So you could have binary classification. That's simply if you have 2 categories. Multi-class just means more than 2 categories. Multi-label is a bit different. That's if a document can be assigned multiple categories. So if we go back to topics, for instance, it could be that there is a topic called politics, but there's also a topic called, say, nature, and it might be that those 2 intersect in climate change, for instance. So suddenly a document could have multiple topics. So in this case, we would be dealing with a multi-label classification. Right, so what I will focus on today is binary and multi-class classification, so kind of the simpler kinds. So document classification is of course only one thing that you can do with natural language. I have included several more examples here, which I won't go into in this lecture at all. So this is primarily just to give you some keywords that you can search for if you would like to. So I will just briefly talk about the 3 main categories here. So we have token classification. That's if you don't want to classify an individual document, like a whole document, but you want to classify the individual tokens or words occurring in that document. So think of, for instance, if you want to extract all the locations in a document. So suddenly you need to classify individual words in that document, whether or not that word is a location or not. So that would be an instance of token classification. Clustering is if we have a bunch of documents and we want to cluster them in, say, categories, or we want to cluster them in some way or another. Maybe we don't know what the categories are in advance, so we want to cluster them without imposing any categories in advance. We also have text generation, where I included some examples here where, just to mention one of them, we could say text summarization, which is you give it a long document and the output of this text generation model would be a shortened version of that text. So again, these are all topics that are currently, like, there are models in place and there's a lot of research going on in those fields, but we will not be dealing with those in this lecture. So we will be dealing with the document classification part. So we have these at least 4 different topics or different categories of NLP. So what they all have in common is this notion of text representation. So text representation is that we want to somehow go from just having a sequence of characters to converting that sequence of characters into vectors or numbers that we can then deal with mathematically. So text representation is then just the field or the method of converting text into numbers. So a popular example here is, so this is, say we want to convert text into 2-dimensional numbers. So then we would want some kind of relation that resembles this, that if we take the relation that king has to queen, that relation has to be roughly the same as the relation man has to woman. That the only difference between these words are gender, and that that is reflected in similar words that are also distinguished in the same manner. So somehow that we have a, you could say, semantic representation of these words. We can plot them in a coordinate system and work with them as numbers from there on. So we see, for instance, here that queen would just be associated with the vector 5, 7, and so on. So it would just be this 5, 7 vector that we would be dealing with instead of the word queen. Same thing for king, woman, man, and all the other at least 170,000 words in English, and then it becomes even more of a hassle when you want to deal with other languages, of course, as well. So to conclude this first part, natural language processing, so it's about extracting information from text, and there are numerous applications of natural language processing in various fields. So we saw, or we will at least see, text classification. I mentioned token classification, which was about classifying the individual words, clustering techniques, and also text generation examples that could be, again, text summarization, chatbots, question answering models, where the model spits out an answer to your question in text form, and various other fields, but these are out of scope of this lecture. So notably, all these applications, they have the notion of text representation in common. So this is, again, a method that we can use to convert text into mathematical vectors or numbers. And in the remaining 3 parts of this lecture, I will be focusing primarily on text representation methods, how it's quite difficult, and kind of introduce a handful of different text representation methods, which are quite different, and some are better than others, and we will be comparing them as well. So lastly, here at the end, I've included some references in case you would be interested in the things that we would not have a chance to cover in this lecture here. So this includes some of the token classification topics in chapters 8 and 13 of Jurowski and Martin. So I will include a link in the description below. And also chapters 23 and 24 in the same book concerning some of the text generation methods. Right, and that is it for part 1.